All right. Okay, yeah, so just let me in. I'm going to be talking about queuing systems. I want to start by just pointing you all to the input files that we're going to be using. So we're going to be dealing with a remote system. Who here has access to Agave or Saguaro already? That's good. That's very good. Okay. So I would recommend just SSHing in and then getting these files. So this is it. Profits. Just going to put that right there. So.
Can you just write the git clone command? Just please.
You're doing for everything from Saguaro?
I'm going to be using Agave.
What do you mean?
Agave? It's close to that. I think it's replacing Saguaro. So,
It's the better Saguaro.
yeah,
Good to know.
yeah, it's good Saguaro. Yeah.
Probably lost my Saguaro for a long time ago, maybe 10 years ago.
Okay, this is gonna show of hands who doesn't have it. So yeah, or you still do
Maybe you can write the SSH command for Agave. I don't know. I mean, I have it set up to automatically do it, but
well, username, I'll just as if it was me. And then that will just be your ASU right password and username. Okay, well, suppose I'll get started if we're ready. Ready to go? So, basically, in essence, what you can think of as a supercomputer is basically a series of interconnected computers. Each computer will have its own processor and graphics card if those are installed. When you first log into Agave, there's a login node where everyone else just kind of appears, and that has, I think, 8 cores, and it's not really meant for computation. And that's connected to a bunch of compute nodes, which have some name. I think they're CG. And then so on. And some of those have certain features. So this one might have a GPU that you can use for accelerating your computations. That's not right. There we go. And then these could all just be only CPU. So I'll show you that landing page. So when you first get into Agave in particular, it'll tell you how many CPU hours you have, and that is a measurement of how much computation you can do. So if you reserve 8 cores and then you use 8 hours, that's 8 CPU hours that you've used, and that'll show up on your balance there. But this is the login node.
So what was the command for that?
Sorry, for what?
Command for knowing the number of SUs you have there.
You can do my balance. No, get you that. So, and I said previously, but just to kind of make it a little more clear, you don't have very many cores. In fact, you have 8 cores available on the login node, and 8 gigabytes of RAM, and that's not very much compared to all of the actual compute nodes that you have. So you shouldn't be running analyses, actual computations on here. This is mostly just meant to set up your systems and then actually submit them for the compute nodes to go to. So the environment that you're going to be dealing with inside the login node is actually fairly similar to what you're going to be dealing with in a compute node. So you'll have your home directory. So everyone gets one, and you can see everyone's home directory. You can't read anyone else's, but these are all the people that have accounts at least, or that have used it. And then you have Scratch space, so you can go to Scratch. So in here is where you're actually going to be doing all your writing. So you don't want to write directly on what's called persistent space, basically where you land when you log in. It's not good for I/O. You don't want to slow everyone else down if you keep writing to that. So you want to do all of your computations in Scratch space for the most part. Yeah. Now, once you get into the login node and you want to start actually doing some work, it's useful to know what is available to do work. So you can go to give me a second. So if you want to get information about the actual cluster, you go to rcstatus.asu.edu/agave/index.php. Yeah, I didn't know. You can just find it by going to Agave cluster status on Google with ASU, and you should be able to find it. Yeah, so it's the first thing that comes up. It's going to require you to log in through ASU. So what you want to look at here is the concise Agave cluster status page. So these are all the compute nodes. So these are going to be these blocks here. And you can get information about them and just scroll over it, and you can see, for instance, this has a Broadwell processor. So if you have software that runs better on Broadwell, for instance, you would want to use these. I don't know if anything actually runs better on Broadwell, but let's just say it did. So you have 28 cores that you can reserve, and they're not being used right now, so you could get a lot of computation done if you're not real picky about the type of processor. So all of those are considered. So where it says features,
You went to running jobs or pending jobs? Sorry, a little bit behind. So when you get the screen, you got running jobs?
you go to the concise Agave cluster status page. Yeah. And so these features here are constraints. So when you're actually requesting, when you're requesting an allocation for resources, you can feed these in. So if I only want Broadwell, you can put a command in and it'll say I want only Broadwell, or I only want MPI. So you can select specific blocks out of here just with those keywords. So I'm just going to start going through the demo now. So if we want to get one of those nodes, for instance, we can say interactive, and we only want to request one. I'm not going to give any constraints to start. I'm just going to get us somewhere where we can do computations. And I'm going to say I only want one core from that node, and we'll say we want an hour. So we'll do so this time says 0 days, 1 hour, 0 minutes. And so then it waits, and once it finds one, it'll tell you. Okay. So now, if we look at what's being used, you can see that almost all the cores on this node are being used, except this one, and that's mine. So I can do whatever I want with that core, and whoever this person is the one who's causing all this ruckus here. Now let's say I'm going to do exit to get out of that. So this will take me out of the interactive mode.
So it has 28 threads on one node. Is it the way to set up now?
Yeah, 28. Wait, sorry, what?
Threads, right?
Mm-hmm. Yeah.
Do you know what is the memory panel? I'm sorry, I'm asking questions. But
Memory for what?
what is the memory panel?
I don't know what it is by default.
That will give it in the H12. So probably it's give it in
Well, I would assume it's this memory divided by 28.
You can
But you can request more, I think.
you can also look in the status page. If you go over any of these things, it tells you that it's 128. And if you scroll down, there are a few serial nodes, I think, that have 256.
You hit auto adjust on the projector.
Is it not auto adjusted?
It seems like there's like one character on the left side that's cut off.
That's the alignment thing.
No, it's.
I think it's on the block.
Yeah. I think that's more actually moving that thing.
Yeah.
Yeah. I have an elegant solution for this. There we go. Perfect. So, and if we wanted, for instance, the entire node, you could just say n, there's a lowercase n to 28, and we wait, and then it will eventually give us one, and you can see that in HTOP we're given the entire node to do as we please.
So some of the nodes actually mix. I'm sorry, is it allowed to ask questions? By the way,
Yeah.
I need to ask the
Yeah, of
first
course.
question. The first question test is allowed to ask questions. So on that table, there are allocated, there are idle, which I understand, but they're also mixed. Is it allowed? Can you allocate for yourself half of the nodes, or what means mixed?
Yeah. So so if I exit out of here, I can say explicitly, let's say I want 14. So lowercase n, 14.
Yeah.
And then it will give you half of a node, and you can see that other people are usually using some of it. Yeah. So you can see that half of it is occupied, and then we have about 14 others that are open for me to use in this case. Does that answer your question? Yeah. So that's interactive, and you can do all of your computations in there, but usually that's not the best of ideas, especially if you have long jobs. So let's say it runs for about a day. You don't want to sit there and have that open on your laptop. You don't want to accidentally close your terminal, because then that'll kill your job, or you get disconnected from the internet, that'll kill your job. So that's when you start moving to queuing systems, which is what this talk is primarily about. So I wrote a couple submission scripts in here, and they go over different topics. So I wrote this so that you guys could go back to, after the talk and actually get an idea of what each of them does. So I'm going to go to the simple script first. And so
Sorry, that's in the queuing dash systems repository that we just cloned. Right?
yeah, that was just cloned, yeah.
And can you show in history how to get all your scripts so that I can copy to my directory? I'm behind because I requested the
Oh, yeah,
account. Now I got the account. Now I want it.
Okay, so let's see. I'm really bad at navigating here. It's not a shortcut. So.
Yeah, I just came from DC, so I'm behind everybody. So how do you get?
So
to this page?
I would just go to Google and then look up GitHub Bechstein Lab queuing, and I'm making the assumption that'll work. Let me check.
Yeah,
I have the link I can do.
yeah, I was just saying if you write out the git clone command to the board.
Oh, yeah, I can do it.
Yeah, I know copy and paste is not going to work, but
Good old-fashioned copy and paste.
yes.
That won't work for everyone if they don't have a. I'll just write that up there. Partially dyslexic. Oh, this is going to be broken across multiple lines. It's just continuation, no spaces.
Capital B on that side.
Oh, thank you. Has everyone had it copied over? Okay. So I'm just going into the simple script directory, and I'm just going to take a look at what's actually in there. So when I did the interactive command, I gave a capital N flag like this, and I put a 1. So anything that you could type into interactive as an option can also be put into a submission script, just followed by this #s badge. So here we're requesting one node, 1 core per node, so 1 core total. For the partition, basically the group of nodes we're interested in accessing. So for instance, these all have GPUs, so that might just say I only want to select from this group. And then the queue is, from what I understand, is the set of rules that you're going to be following in the queue. So there's the wildfire queue is, I think, just open to everyone who has an account. So we're basically requesting from a certain subset of nodes with a certain set of rules. So this is what you're going to be typing from most of the time. And then what we want to do is we want to get output files for the standard out and then standard error. So if we're running an application and it puts errors out to standard error, then this will give us a log after everything's done, because we're not going to be able to access the node while it's going. And then the job name, just so it looks nice later on when you're looking at a big list of jobs, you know what it is, and this is a simple script.
So I just want to quickly say we're using the special physics GPU 1 thing, so that's a new addition to the cluster. That's high-end GPUs that Banu, Matthias, and I paid for. And we're using this so that we're ensured that we can always get on for this workshop.
I know you can, though. But in principle, you should be able to just select all the constraints that go with that with the C flag. So if you're doing interactive, you want something that has Broadwell, C, Broadwell. So in principle, they should all be the same.
That's not my question. You can always access it into a simple
Into a
cluster.
login.
No, yeah, exactly. So if you want to access a particular cluster, you can say access it CG1. But if you want to ask your script to specifically run on only that particular node, how do you add that line in the script?
I'm not sure what it is, actually. Do you know of any way to access for the specific?
No, I mean you can ask if you want the normal or the fast nodes on the GPU partition, but I'm not sure if you can specifically ask for a certain machine, and I'm pretty sure you're not allowed to do a raw SSH into a node.
Actually, we can.
Okay, so that's probably something that should be blocked.
So there's a bunch of modules available. So module being either compiled software or libraries in order to build software or scripts, for instance. You can get a big list of them using module avail, and it's I'm never really sure why it's so slow, but it is. I mean, I guess there's a lot on Agave, but eventually it should spit out a bunch of stuff. There we go. So these are all of the packages that are available from the administrators of Agave. So if you wanted...
do we have them explained? I can recognize many of them, but not all of them. So do they have them explained somewhere on the website?
No, I don't think they explain them. I think you can just select them.
Well, we need to know what to select, right? So
Yeah.
I can select, of course. Right?
Yeah. So if you need to compile, I don't know, GROMACS, for instance, for molecular dynamics, you will probably need MPI. So you need OpenMPI, for instance. So you can just use that. And the reason why they do this is so you can actually compile with a version that you. So if you need it to be reproducible, you can always get OpenMPI 1.10.2, for instance. Even though there's new versions available, you might need to compile an older version if you're trying to reproduce someone else's results, for instance. So they make pretty old versions available for compilers.
Compilers are listed in the modules, or compilers come separately?
Sorry?
Compilers are listed in this list of modules, or they come separately?
They should be listed in here.
That's what I'm looking, so I don't find any ones.
Should be a couple of Intel compilers in there.
I didn't tell, but it's not clear.
I would expect like GCC to be in there. It looks like they probably have the Java compilers.
There are the Intel compilers. So they have 2018.
Yeah. So let's say we want to use just the pre-made GROMACS. So we can do module load, GROMACS, and do 2018.1, which is the one that's available on there. If you do tab, it'll do tab autocomplete. So if I do module load, GROMACS, hit tab a couple times, it'll give the versions that are available. So we have 4.6.7, 5.4, and then what? What? There should be a 2018 there that I used 20 minutes ago. Oh, it may be because I already loaded it. Would it exclude for? Yeah, it would have errored if it didn't. Yeah, okay. It's there. It loaded it, so I'm not sure why it wasn't listed there.
Well, they have actually command module list, which has extensive list of the modules. You were on it.
Module list. Oh, just for the loaded ones?
Yeah.
Yeah. Yeah, okay, you can see the ones that are currently loaded, and I guess those are the ones by default.
No, module list is a single word, it's a command.
Oh, wow. Okay, well, that's good to know. Thanks for pointing that out. Okay, cool. So, just to show a little more how to use them, I created this module script here. So it just kind of goes over the basic thing that we did previously. Request one node, one core on the physics GPU cluster using wildfire queue within a module script. And there's different versions of Python, for instance, on the module list. So you can module load Python 3.5.1, and then I just printed out basically the version, and then I module purge, so that's just resetting to the initial state for modules in your environment. And then I loaded 3.5.2 and then printed that out. And so then that should just spit out a standard out file that shows that it actually does what I'm claiming it does once it's feeling like it. Just copy back slowly, looks like.
You can just do a watch on your OS. What?
I'm not really sure why it's doing that though. Okay, it output something weird the first time, I guess. So you can see that we said we were going to load that, we loaded that, we purged, then we said we were going to load that, and we loaded that. So now we have all of that. Any questions about modules? There's a pretty self-explanatory now. Okay. So what are the reasons why you might want a supercomputers to get access to the GPUs? Because most laptops probably don't have one, so you might want that for accelerating your simulations. So in order to grab GPUs, you just add an extra option here where you basically say I want a GPU, and then in this case we have 1080 GTXs and we want one. So on these nodes there are 4, but we're only selecting 1. And then we're running NVIDIA SMI to actually get the output and to show that we have GPUs. So if I did just interactive, and I just got thrown onto some random node, you're going to see that there wasn't a GPU, or at least it had trouble communicating with it. So if we do SBatch GPU, NVIDIA SMI, SOE, wait for it to copy back. And you see that now we have GTX 1080 that's available with nothing running on it, and that's good. We don't want a bunch of people piling onto the same GPU. Yeah.
Can you try the same thing requesting 4?
Is that 1/2? I'm not going to mess with it.
When you request 1 or 3 or 4, what are really requested? It's not the entire GPU, just GPU threads, or what you request?
The entire GPU.
Can you request 4?
Well, if there's 4 GPUs, so it's like if you had 4 GPUs and that just assigned to that node.
The node, yeah?
Yeah.
Oh, I see.
So now we have 4 total GTX 1080s. So once again, with nothing running on them. So that would have been. Oh, didn't submit that again. Oops. So that would be 4 GPUs with 1 thread, which is a kind of very silly request, but that's fine. Okay, so now that I've showed really how to get these basic requests going, I'm just going to show a quick working example how to do this. So this is going to be a GROMACS simulation that uses GROMACS 4.6.7, and it just simulates benzene floating around in a box of water. So I'm going to go through this. So this has more corrections for errors that could have happened where it doesn't copy back correctly, for instance. Yeah. So requesting 2 nodes with 48 total cores. We're going to use the physics GPU cluster. I mean, we've seen this. Difference is the name is benzene and water, and I give it an hour. It's not going to take an hour. So I'm defining GROMACS version 4.6.7, some specific information for GROMACS. And I'm defining the work directory where it's going to be doing all its writing, because I don't want to write to persistent space because it's not really made for that. I'm going to tell it to bake the work directory and all required directories to get there. I'm going to test it to see if I can really, that it actually exists. So if this doesn't work, it won't necessarily stop our script. So we want to check that it actually exists now, and if it fails, print out to standard output that we couldn't make it, and then exit out so it fails and we can see that. And then this will also be in the log file. So then we want to copy the required TBR file to the work directory, and then we actually go into work directory to start doing some stuff, and if it fails, also exit. So I start out by module purging just to get rid of anything that might be in the way. So if your environment's messed up to start, that'll just take care of it. And then I'm going to load the GROMACS version that I specified up above there. And then load CUDA because it should, in theory, load it by default. Load it automatically once you load GROMACS, but for some reason it doesn't. I think they need to change their definition for it. And then I'm going to have this use MPI run so it splits the work over multiple nodes, so it's able to communicate across the nodes. So I tell MPI run to just take the number of tasks, and that's how many MPI processes it's going to create. And then we use MD run, which is put into our path by this line here. We load in the TBR, and then we say run it for 10,000 steps. And at the end, we copy back. And in reality, that should have something in here where if it fails, for instance.
I'm not familiar with GROMACS. So mdrand underscore MPI, is it standard name for GROMACS, or how does
it normally goes just by MD run, but because this is an MPI enabled binary.
This is the name of the code that the system will recognize as a program, right? So
yeah. So that's loaded in. Right? Yeah, that's loaded. Yeah. It's GROMACS and it's loaded in there.
MD is usually not configured.
So then we do SBatch working example. I'm going to just watch SQUI Kenney, because that one will actually, this is the first, I guess, interesting one. You can see how long it's been running. If I recall, that only takes 13 seconds or something. Or more. So, yeah, it's just running a bash, basically a bash shell somewhere else and doing the computations. And once it's done, it's done there. So now we have all these new files that came out of our simulation, just because I told it to grab everything from where I was and put it back. Any files that were created. If you only wanted, if you didn't care about, for instance, this EDR file, then you could just copy and say, only give me XTZs and everything else that you really wanted, have a copy of those back. And so standard out hasn't put anything out. And standard error, this is an old version of GROMACS, so it's complaining. But this is the output of GROMACS, typically what you'd see if you ran this locally. And you can get information, for instance, that it would output. So GROMACS puts the performance at the end, so you know if something went wrong. I mean, that's a pretty good number.
So in your case, it did not produce the standard error, or it did?
I did.
Because I just ran it and it generated standard error, which has no file directory.
You said what, sorry?
If you look at your standard error output, what do you get there?
Like that?
Okay, so I got something different, but I obviously I ran your script.
Did it?
Generated no such file directory. Probably I just simply ran your script. So.
It also says no such file directory ignored, that one.
Yeah.
Oh, I see.
Did you get any of this output?
No. Probably still ran. So.
That's odd.
I mean, I ran exactly the same thing as you, and I get the same. I mean, same performance and everything.
Okay.
So,
Yeah, I'm not sure. Maybe it's.
do you get a file?
Oh yeah, realcom.o.
So this is error.
Yeah, but this one just standard out.
Yeah, so there's two files. There's going to be a standard out and standard error.
I think I moved this standard error, right?
So this one's, you wrote the standard out, but you wrote dot usage and standard error.
Yeah, but I mean, standard error gives this the GROMACS output. I mean, that is what GROMACS tells you. So.
Did you get it?
I'll do it.
Yeah, hopefully, see that's the standard error, that's the standard error.
So does anyone have any
Yeah,
more
I
questions?
got the same output. Right?
Okay, cool. Any more questions regarding this? Is anyone having trouble with that? Because this is kind of what actually working on the cluster will look like, so I want to make sure that everyone kind of gets that. All right. So there is a limit to how long you can run a job. I believe by default it's a day. So there's going to be simulations where they've actually run for many months, and you need to keep those running for many months in order to complete them. So you can't just say go and then wait, because it'll be killed, and then you'll have to start that every day manually, for instance. And if it doesn't terminate properly, then you're just going to have discontinuities in your simulation, and it'll be kind of messy. So we have a script that was developed in our lab. It's called QSubDependence, and that should. Yeah, and I included the actual software in this repository, but if you go into there and then you say git remote v, it actually contains another repository. So if you want access to that, just look up XMLab